Well, welcome. How's it going, everyone? Welcome to another edition of the DataEng Meetup. My name's Peter Hansons. Really happy to be here with you all. Hope your Thursday is off to a flying start. Yeah, really excited about the two speakers that we've got today. We've got Roko Kruse, Head of Customer Success at Redpanda. He's going to be giving us a bit of an intro to Redpanda. It's a Kafka-compatible streaming data platform for mission-critical workloads. Really excited. I know a lot of you have sort of been mentioning Redpanda in our Slack group recently, and so it'll be finally great to hear from the horse's mouth, if you will. I wasn't comparing Roko to a horse. He's not in any way, shape, or form. Then we've got Tim Woods, head of sales and business strategy at Datafold. Datafold are another, extremely exciting startup in the, data observability, data quality space. I think it's a hot topic at the moment. So really excited to hear from both speakers today. I think there'll be a fantastic set of presentations, and I really do hope you learn a bunch. So without further ado, I might just add Roko to the live stream. How's it going, Roko? Where are you dialing in from, by the way?
Thanks so much, Peter. I'm calling in from San Francisco, so a little later and still Wednesday, so I'm a little bit in the past, if nothing else. So
Yeah, nice. But, I'm sure whatever you've got is definitely cutting edge for us today. So very much looking forward to your talk. And without further ado, we might just dive into that one. So take it away, Roko.
perfect. Thank you so much. Welcome, everyone. I'll take you through Redpanda, just a high-level overview, and we'll talk about a few sort of key topics. So what I'll cover today is the history of streaming, an abbreviated history of streaming, and a little bit about Kafka itself. I'll be talking about Kafka because we are very comparable. We use the same exact API interface, so all the clients and everything else work with Redpanda. So that's why you're going to see the comparisons to Kafka specifically through this. So I'll talk about how Redpanda compares to it, get into some of the internals of Redpanda, and then also how you can get started with it quickly and then answer any questions that you might have at the end. So a little bit about Apache Kafka. I'm making the assumption, hopefully, that most people have heard about a Kafka or have used Kafka. It has been a project that's been around since 2011. And what it was really designed for was to be an event store. So allowing people to send events to it that then could be stored for later retrieval to downstream systems. So this evolved out of messaging systems like RabbitMQ, from the different MQ type systems. This was sort of a different approach for sending larger, sort of sets of messages across a system. It was really focused for higher throughput and was really initially used and developed out of LinkedIn for shipping HTTP logs from web servers to Hadoop clusters. It's fully written in Scala, runs on the JVM. It uses the page cache, which is really kind of the file cache in a Linux operating system, which made a lot of sense back in 2011 because Java was pretty notorious for having garbage collection issues, and you probably didn't want to give it much more than 16 gigabytes of memory. So using the page cache was definitely the ideal choice. And also it does things around delaying writing to disk because 10 plus years ago, you were running on spinning disk, most likely. SSD was super expensive. And so it made sense to do async flushes to disk using the page cache. And then also, back then as well, there weren't a lot of consensus tools, or Raft and Paxos were still relatively new. So Kafka actually uses something called Zookeeper for doing consensus within the system. A lot has changed though in the last 10 plus years, or since 2011. Hardware has changed dramatically. We see a lot more cores in a system. You can get easily get a machine from AWS that has 96 cores and above. You have a lot more L1, L2 cache on the chip too as well. You have huge amounts of memory on a system. And this gets a little challenging with a number of different systems being NUMA aware, because you don't want to go across and do high latency access to different memory in the system. Networking, 10 years ago, you were lucky if you got a gigabit. connection into a box. And nowadays you can get a box from AWS with 100 gigabit connection into it. And most SSDs are much cheaper and much more accessible than they were in the past. We've also seen a lot around containerization. So simplifying sort of how you run in containers and in cloud environments has really become critical. And we've also seen people really take these event streaming platforms like Kafka and interject them with mission critical workloads that they might have, whether they're transactional or operational in nature, where the reliability and latency and tail latency is super important for those types of workloads. So what is Redpanda? We built really, in the most simplistic terms, it's a modern streaming platform that is Kafka API compatible. We really focus on doing high throughput, low latency with strong durability guarantees. So this was a project that was started back in 2017. The core developers come from companies like Akamai, have worked on like Ceph FS or Ceph file system, and also have worked on things like Cosmos DB and other distributed storage systems too as well. We are a source available company, so we have our software underneath a business source license that allows you to pretty much do anything with the software that you wish, as long as you don't make a public service that competes directly with Redpanda itself. So kind of the AWS clause, if you will. And you can actually see all of our development and PR and code itself out on GitHub. And we've really focused on overall performance, safety, and operational simplicity, which I'll talk about in more detail. So how do we compare with Apache Kafka? And maybe I'll use this moment to kind of talk a little bit about sort of the concepts around Apache Kafka. So Kafka and the Kafka API, more specifically, has a few different sort of key concepts to it. First one is around producers and consumers. So you have producers that are producing messages and sending those messages to a event streaming platform like Kafka or Redpanda, and then you have consumers that are consuming those messages. And then the messages themselves, they get organized into this grouping of namespaces, topics, and partitions. And so you can think of, the partitions as the lowest unit. It's pretty much a shard or kind of a key range, if you will. And then a topic is a grouping of partitions, and a namespace is a grouping of topics. And for those individual partitions, you have leaders and you also have followers. So a partition, typically you'd have multiple copies of the data, and you would have a leader for that given partition, and then the followers that go along with it. There's also the ability to do transactions. So you can actually produce a message to multiple topics and do it in an atomic fashion. There's a schema registry that allows you to define a schema that goes along with a particular topic. So you can say that this particular message follows this Avro format or a protobuf specific schema too as well. And there's also an HTTP proxy that has a JSON type interface. These are all things that also exist inside of Redpanda as well. And because of this, you can use any piece of Kafka software that exists out there today, or Kafka client software. So let's say you're using Spark or Flink or any of the Kafka Connect frameworks. Those work directly with Redpanda out of the box. So you don't actually have to change any code. If you're using Apache Kafka, you can just really just change it to point directly to Redpanda with really no modification of your system. So where do we differentiate from Apache Kafka? So we are much simpler to operate, and I'll talk about some of those key points here in a moment. We've also really focused on the overall reliability and being safer and faster. And I'll show some of the benchmarks that we've done on ourselves, and how you can actually get information about how to do those yourself if you wish. But we have incorporated the RAF protocol with the system. We do direct IO, which is a lot different than using the page cache. So we're not putting the data into, we're not really using sort of the coarse grained page cache of the Linux kernel. We're actually doing direct management of IO and memory within the system itself. We're fully written in C++. This is, typically I get asked why didn't we do Rust? And it's we started back in 2017. So, back then Rust was still fairly immature. But that's why we chose C++ then, and has been active developed, or the system has been actively developed for some time. And we also use a library called C star, which I'll talk about the specifics of what C star provides us as well. We do also have transactions, and I have a little bit of a comparison of how we can work, or how we perform with transactions compared to Apache Kafka. And then also we have a few other enhancements I'll talk about, which is shadow indexing and WASM. So operational simplicity. We've really tried to take the model of, just have the system do the right thing and not have to really require a heavyweight tooling around Redpanda to make it work out of the box. So we're 100% driven through a CLI interface called RPK, which is really short for Redpanda Keeper. We don't rely upon any external systems. So we don't have Zookeeper or etcd or JVM or anything like that. We're a statically linked binary. It's a single binary that also includes the HTTP proxy server that I was mentioning earlier and a schema registry. So these aren't separate processes you have to run on separate nodes or separate pods within a deployment. We also do things like automatic leadership and partition rebalancing. So when you have let's say a node come in and out of a cluster, typically you would have to go back and rebalance the leadership using something like cruise control. We just do that automatically within the system. Or if you add a node to the cluster, we'll automatically rebalance the partitions to that node as well. We also do things like auto tuning of the kernel, so setting specific parameters for making sure that we have specific schedulers and getting the best performance that we possibly can out of the kernel itself. We also are pretty opinionated on file systems. We really like and prefer XFS because it allows us to do pre-allocation and also out of order writes directly to it as well. We have a native Prometheus endpoint. So every node has a Prometheus endpoint, so it makes it pretty easy to integrate with any sort of monitoring system that you have. We also generate a Grafana dashboard that you can use too as well. We provide a Docker image. We have a Kubernetes controller, Terraform and Ansible for all the different cloud providers like Azure, AWS, and GCP, which can get you up and running in those different environments pretty quickly. So let's talk a little bit about Raft and what that does for us. So, Raft is the consensus protocol and the replication protocol that we're using for all data within inside of Redpanda. We do have a Raft group that stores all the metadata and cluster state within the system, and then every partition is its own Raft group within Redpanda. Raft does require an odd number of replicas, so the default is 3, but you can go to 5 or 7 too as well. This really allows us to have a single fault domain, so we don't have to, like Apache Kafka, which has Zookeeper and then also has what they call in-sync replicas. You have 2 different ways that you're actually sort of sharing state, and that creates multiple fault domains that then you have to troubleshoot or investigate if you have an issue. For us, we have one way in which all consensus and replication is happening. Raft is also great because of the fact that what happens is that as writes come in, they come into the leader, and then they're dispatched out to all the followers in a parallel fashion. And we only have to wait for a quorum of them or a majority of them to come back before we can actually move forward. So this allows us to write out slowness of individual replicas, and leaders can act to producers, like I just mentioned, once the majority of the replicas have responded. So what does that actually mean? What does it mean to be able to write out these particular types of issues that we see? So this is actually some graphs that we have created in the chaos testing that we do within Redpanda on a regular basis. And we actually, if you go to our GitHub repo, you can actually find a chaos repo within there that has all this code, so you can actually run these and get these graphs yourself if you wish. And so we run this on Kafka and Redpanda. And for one of the followers of a partition, we just went in and did a kill-9. And you can see that we actually have unavailability for a short period of time on Kafka for that particular partition. Doing the same operation on Redpanda on one of the followers, you can see we have really no interruption of service, no increase in latency or anything from that standpoint within the system itself. So being able to have Raft with this type of system allows us to have this type of uninterrupted service for our users. The other thing that we've done is we've actually modified the FuseFS file system and allowing us to interject faults and slowness on disks. And so we did this where for Kafka and for Redpanda, we added 10 milliseconds of disk latency for a particular follower, not for the leader. This is just the follower, mind you. And for the follower, on the Kafka side, you can see that latency does increase dramatically with just the follower slowing down. And this is because the in-sync replica way of doing replication versus the Raft way of doing replication allows us to have a consistent, non-interrupted response to that particular sort of slowness or fault injected into the system.
Quick one,
So
Roko, you mentioned that you're happy to take questions throughout the presentation. We've got one from Clive Asprey of Snowflake. He's one of I think he's the director of sales over there, and he's asked, is Redpanda architecturally similar to previous brokerless messaging solutions like ZeroMQ and Aeron?
That's a good question. I have not. I've heard of ZeroMQ, and that's the first time I've heard of Aeron. Um, so I'm not quite sure. I probably wouldn't be able to answer with a lot of authority, but I'd be happy to follow up in a community Slack conversation.
Sounds good.
But yeah, a lot of those MQ systems, they were much more focused on allowing to have like single message or working with a single message at a time, and really just not really didn't have a lot of the same semantics as Kafka itself. We've kind of seen this with things like RabbitMQ and whatnot, where we've had particular users go from RabbitMQ to us, and their concern initially was around sort of seeing an increase in latency because they couldn't do single message acknowledgement. Everything is batch based when it comes to the Kafka API. But we actually had a great blog post that Alpaca wrote themselves, where they had done this comparison, and they actually saw a huge performance improvement. I think going from 150 milliseconds to a half millisecond as average latency. So that concern around sort of working with batches versus working with like single messages was not founded. But I know that's probably not the complete response to your question. And if you'd like to have a further conversation, please do find us on our Slack community channel, which I'll have a link for at the end, where you can we can dive into that a bit more detail. So diving into the other aspect that I brought up, which was around the C-star framework. So this is a framework that's used by other open source platforms like ScyllaDB, and there's a few other projects out there too as well. But what C-star does, which is really interesting, is that it treats a computer like a distributed system. We're seeing machines today that have a huge number of core counts, and instead of just creating large number of thread pools and allowing those thread pools to do context switching wherever they want on the system itself, this takes a separate approach of actually treating each individual core as a full system. And so what Redpanda does is when it first starts up on a machine, it looks how many cores are available. It'll launch that many threads, and then we'll tie or pin that thread to a given core. This allows us to do things like having minimal context switching. There's really no locking because everything's happening within that individual thread or individual core, and also allows us to be aware of memory as well. So we're not having to see like L1, L2 caches get warmed back up again. And we're also not going across like NUMA regions within a system as well, because we're always going to be pinned to a given core that we're working with. Also, the C-star framework gives us async programming, or a fair bit of async programming. This was, IO urine is kind of the sort of, the kind of the new hotness to a certain extent. And a lot of people have asked us like, well, does IO urine or does C-star make use of IO urine? And it doesn't, but all IO and pretty much everything within it is async. So there's really not a huge benefit with going with IO urine. IO urine provides a lot more benefit for systems and for frameworks that are not asynchronous to begin with in their design. We have done a lot around direct IO management. So what this really means is that we're not using the page cache in comparison to Kafka. So we do have thread local object cache, which avoids global locking. And because of the fact that we manage the full memory ourselves, one of the main issues with the page cache is that if there is a request for historical data, so let's say you have a consumer comes in and asks for the last 6 hours worth of data, then the files that are needed to satisfy that request get paged into memory, and then your real-time, near-time data gets paged out of memory. And so now all of a sudden you can see large spikes in your real-time readers for that to satisfy that historical request. Because of the fact that we're managing all of the memory, we can make sure that we allocate a portion of it to the historical requests and the real-time requests. So you don't see these types of sort of cache blowouts happen within the system. We can also do a number of things around read ahead to make sure that we know that we see this consumer is maybe slightly behind or is reading historical data, that when we can read ahead onto disk into that cache as well, which is something that's a little bit harder to do when you're using the page cache. And then also we do things like out of order IOPS, which I had mentioned previously, that helps us amortize overall flushes across the different partitions. So with all of the things that we've done in that regard, this is the sort of the final result. This is a benchmarking that we did a little while ago in comparison to Kafka and Redpanda. We used the Open Messaging Benchmark, which is a Linux Foundation project that works across a number of different sort of event streaming systems. And what this was running 500 megabytes per second on a 3-node cluster inside of AWS. We're using i3EN 6 extra large instances. The reason for that is we actually wanted to run the test for a long period of time. And if you use anything smaller than that, you get the up to 25 gigabits per second, which really means in AWS speak that you have 25 gigabits per second for about 8 to 10 minutes, and then 8 gigabits per second for the rest of the time. So to make sure that we weren't actually being throttled by other particular sort of limitations or bottlenecks in the system, we went with the guaranteed networking and for the particular instances. So this is that 500 megabytes per second I was talking about, or I just mentioned, using 1 kilobyte message size. And you can see this end-to-end latency for Redpanda is right around 2 milliseconds. And for Kafka, sits right around like 15 milliseconds on average within the system. But the story that's much more interesting is more the tail latencies of the system. So we see a lot of people over provision their Kafka clusters because they want to avoid these massive tail latencies. And here in Kafka, you can see that you get up to tail latencies of about 3 seconds for the same exact workload. For Redpanda, we're at about 120 milliseconds for the kind of the max latency all the way out to the 6 nines within the system. And then the story is also the same when we start talking or comparing transactions. So we have implemented very effective transactions within the system where this is actually doing, picking 2 random partitions and showing kind of the average throughput of doing a write between those 2 random partitions. So you can see here that we're able to do upwards of about, on average, it kind of goes between 6,000 to 5,000 transactions per second in comparison to Kafka's 1,000 transactions per second. And then as you can see that as the number of threads and number of clients are increased on the system, Kafka increases linearly with their overall average latency, whereas Redpanda stays fairly consistent, increasing at a much slighter slope than with Kafka. So what else are we doing to sort of, kind of push things forward? The other thing that we're working on is something called shadow indexing. This is in a preview state right now, and it's going to be generally available in the next couple of months. But what this allows us to do is it's very similar to tiered storage. So as data comes into Redpanda, we write it to local persisted disk, and then we also upload it into an object store like GCS or S3. This allows us to have a smaller retention window locally on the machine itself, and also to handle historical requests in the system. So if you asked for data from 2 weeks back, we would actually pull that data from the object store, cache it locally within the system, and then send it back to the client without the client ever being aware that the data actually came from the object store behind the scenes. And we also have a very aggressive read ahead cache on this. So your first initial request for pulling this historical data might be slightly slow, or it might be a little bit of a lag. But then once you actually start consuming more data, we're always fetching the next sort of segment within that particular partition. So you're actually seeing really nice high throughput within the system, and it's as if you're reading a real-time stream. The other thing that's in a developer preview as well is transforms that execute within the system or within Redpanda. So we've actually taken the V8 engine and we have that running alongside Redpanda. So as data comes into Redpanda, we persist it onto the parent topic, and then asynchronously it gets sent out to the V8 engine that then you can actually do transforms with. So you can do things like masking data, filtering specific messages if they don't meet a specific criteria. You can transform it to Avro to protobuf if you wish. You could also route it to multiple topics too as well. And then those get materialized onto a topic that then can be consumed by downstream consumers. This is all done on the particular Redpanda node itself. So you don't have any of this data back and forth between, sending the data out to a Kafka Stream application and then having it come back in. Now, this only works on a per batch basis. So this isn't going to replace the Sparks and the Flinks of the world, where you might want to do like windowing or joins across multiple topics or other things from that perspective. But it is going to solve, a large percentage of the workloads that we see out there today that are just doing these simple filtering and other things from that perspective within the system. So just to kind of sum it all up, we've really focused on making Redpanda fast and efficient, overall simple and reliable at the end of the day. There's a few different ways in which you can make use of us. We have a Docker image today. One thing that we've always been kind of surprised is a lot of people have replaced Kafka with Redpanda in their CI/CD pipelines. We actually had one user who went from 15-minute CI/CD pipeline builds down to 5 minutes by just removing Kafka with Redpanda. We also have a Kubernetes operator, the different packages for RPMs and Debians, and also a homebrew install as well. We do provide enterprise support on this. That also comes with shadow indexing, and we're working on a few different cloud options too as well that you can find more details on our website. Getting started is pretty straightforward. You can always, I just have the link for the website. We have a number of different getting started guides. This really just sets up a single node cluster locally, giving it 1 core and 1 gig of memory, and you're kind of on your way to making this work directly out of the box within your system or within your local environment. So with that, I'll just check to see if there's any other questions. I have seen a few comments come in, so I will take a quick look.
Yeah, I actually asked one myself via the live chat, and we will put it out for Q&A as well from the crowd. But what format does Redpanda store its S3 sync data in? Can you read directly from it? So basically, say if you wanted to say ingest data from that S3 sync into say a Snowflake or another data warehouse, Redshift, or use it with Athena, is that possible?
It's technically possible. We have the format itself is not proprietary or anything from that standpoint, because you can take a look at the code. We are considering providing like a Python library so that you can actually read that file directly. But that's something that we are currently working on. But we do have a few users who have read the file, who have actually kind of reversed the C++ code, and it looks very similar to like what a Kafka segment file looks like, which they just read directly to then push it into Snowflake or BigQuery downstream. So.
Yeah, really cool. And cool. So you've got a few links up on the screen in terms of where to get started. So GitHub link, blog. Do you want to take us through a few of those just to see if we get any questions in the meantime?
Yeah, absolutely. So you can definitely check out our code on our GitHub repo. It's all there. We do have a blog post where we do have a number of different blog posts that are pretty technical that go into how we use C-star and some of the lower level details around how we're doing chaos testing within the system. We have a pretty large community Slack location, which a number of our engineers are pretty active on. So if you have any very specific questions, feel free to come there and join us in the conversation. And then also, if you would like to talk further with us, feel free to always reach out via the website too as well to us.
Awesome. Well, really appreciate your time today, Roko. I think it's a fairly new technology for folks here in Australia, but sounds really exciting. The performance metrics that you shared, the ease of use, Kafka compatibility, and the like, I think, make it a no-brainer to at least give it a go. So looking forward to giving it a whirl myself. So Thanks so much for your time. And I know it's reasonably late over there in San Fran. Really appreciate it. Thank you.
Thank you so much, Peter. Appreciate it. Take care.
Awesome. Likewise. Very good. Well, up next, we've got Tim from Datafold. Datafold are the data reliability platform. So, goodbye to data doubt is the catch cry. And and honestly, that sounds pretty cool because I know being a data engineer myself, replicating data a lot, wanting to sort of make sure that it's, arriving completely. And when things break, I get alerted and stuff like that from it. I think that's super, super important. So, really keen to sort of dive deep into what you have for us here today, Tim.
Sure.
And so, whereabouts are you dialing in from, Tim? Keen to know.
Yeah, I'm actually dialing in from Austin, Texas.
Yeah, right. Austin, Texas, like for an Australian, it feels like it's a big university town. I'm hearing a lot of startups, coming out of Austin, Texas. And
Yeah.
I think, is it, Elon Musk? Is he?
Yeah, I
around
bump into him at the coffee shop pretty regularly around the
there? Right.
corner. It's a nice town. I see why people are moving out here. It certainly is a university town. But weather's nice, and generally it's, I think, pretty much cheaper than a lot of the other big hubs. So people are moving here in droves, myself included. I was in Boston for a while before I came out here.
Right. So it must be a good deal warmer over there, I can imagine.
Yes, it's quite nice. It's quite nice. The cold days are not so cold as they were in Boston, certainly.
Yeah, nice. So you're here to take us through data quality, proactive data quality, why culture comes before tools. It's a really good take. I know usually us data engineers are reaching for the tools on the first count. So I fascinated to hear more from you. If you'd like to share your screens, we could get
Certainly.
underway.
All righty, let's do it. Okay.
Awesome.
All right.
All ready to go. Well, without further ado, Tim, take it away.
Glorious. So yeah, thank you, Peter, and thank you everyone for tuning in. My talk is unfortunately going to be a good deal less technical than Roko's, but probably a little bit shorter, so I can get to the good part at the end a little quicker. But yeah, I'm going to talk a little bit about how Datafold looks at the world of data quality, and like Peter said, why culture comes before tools, and kind of some interesting implications about the world of data quality in general and how it's a little bit different from software quality. So to kind of set the stage, right? Data quality, obviously a term that's been around for a really long time. And every company wants data that's high quality, right? But interestingly enough, it seems like, most companies have a really hard time doing this. It sounds like one of those standard data practice, data integration, data warehouse, data quality. It kind of sounds like it's just something that companies should have, but underneath that pretty simplistic term is a lot of nuance that I think often doesn't get accounted for. It doesn't get necessarily properly understood by the business in terms of how ultra high quality data is actually delivered. And so I think there's some miscommunication that actually ends up happening in terms of understanding that what goes into data quality. And so I just want to talk a little bit about that today, because it drives a lot of what we do at Datafold in terms of preventing data quality incidents from happening in the first place, as opposed to just reacting to them, right? One thing I'm going to do is try to talk about this using an analogy. In terms of how I understand things, analogies make it easier for me. So hopefully it helps it click in for some of you as well. So, and please forgive again, my presentation was made by yours truly. I am not someone who does design or makes PowerPoints. So, forgive the poor quality, but hopefully the ideas stick. So this is my relatively rough representation of the software quality iteration cycle. Software is kind of famous for, its ethos, at least in the States, right? They kind of move fast and break things, early 2000s, Facebook and Google kind of energy that sort of ended up driving a lot of what software engineering has become today. And the reason that move fast and break things ethos has worked so well is because software engineering is actually this naturally anti-fragile process. For anyone out there who might be a Nassim Taleb fan. So basically this means that as you move fast, right, and break things, theoretically, as you're breaking something, right, you're actually gaining something. It's, you're able to move fast, and as people run into bugs, they're able to report those bugs, you're able to fix them and keep moving, right? So at the end of the day, when you're going through that iteration cycle, you end up with iteratively better software and happier users, right? As long as you're timely in terms of how you get to the bugs that they have, and as long as you're releasing really cool features really quickly, people are generally happy, right? And so that kind of, cycle of, a bug arises in the code, and then the user briefly loses trust because they're trying to click a button that's not working. And then, they mention it to the team, they chat in or whatever. And then the software engineering team goes in, fixes the bug and iterates. They let the user know, they go in and click the button. Great, it works, and everyone's happy, right? And so I think data engineering actually has, taken a lot of its ethos from the software engineering world, right? There's software engineers, there's data engineers. There's definitely a certain, kinship between the disciplines. And I think that kind of move fast and break things mindset has moved over into the data engineering world, but it has much different implications from a trust perspective. And so with the data quality iteration cycle, this is what it actually looks like. So, you can see that bug arises, a user, you loses trust. So say that's maybe an error in a dashboard or something. And then the data engineering team, right, they want to react and they want to fix that as quickly as possible. And, maybe they do. They jump on it and they fix it. But the thing is that, say it's the CEO or the CFO who is like, hey, I just found out this dashboard I've been looking at for the last few months has been incorrect, right? That is pretty damaging to trust. But once that dashboard's fixed, that CFO doesn't actually have a way, like in the software iteration cycle, to go try to click that button that they were trying to click before and see it work. They really just have to take the data team's word for it. Hey, the dashboard is fixed now. And, ultimately that's okay. But the nature of, the data quality and just the data business in general is all about trust, right? If you could be looking at a perfectly correct dashboard, but if you can't trust it, then it won't actually inform your decision making in a really high conviction way, which is when, data is doing its thing. And so another way to look at the data quality iteration cycle is where bugs are silent and fester for much longer. So this tends to happen a little bit more than it does in software engineering because a number or a dashboard can shift, it can get ignored for a while, and so things really end up multiplying as a result of all these silent festering bugs, and the data team might not even know where they are. And so again, the more issues like this that a data team has, unlike software, actually the weaker the trust gets. Even if overall they're shipping lots of really high quality data products, several high visibility data quality incidents can actually throw into question all of the hard work you're doing. And so it really makes it a totally different relationship that data teams need to have with the business than like a software team would need to have. And it also means that they need to treat data quality a lot differently to ensure that trust doesn't break in the first place. And so, the cost of bugs actually making their way into production is much, much, much higher for data teams than it is for software teams. But the interesting thing is, on top of that, right, the data puzzle is much harder to solve. It's it's almost like there's so much data that's out there. There's so much data that comes from third parties, things that aren't actually in the control of, of the data team, that, it makes this essentially a impossible task. And so data teams then play a little bit smaller in an attempt to manage expectations from, leadership, from their internal stakeholders, to ensure that, they can over deliver on the asks, and they don't try to do anything too crazy, because they know if that starts to happen, then things will break, trust will be lost, and all of the hard work that maybe they've done over the course of years might, go out the window. And so basically, I think, the way to think about data quality and the culture of data quality really needs to come down to this idea of prevention. So, I don't have a ton of slides on Datafold. You can certainly come and check us out, and I can answer any questions after the talk, because I'll definitely have some more time to do that. But essentially, the tools we build help you prevent data quality incidents from happening in the first place, because it is such a high stakes game. It is such almost a relationship game that you need to play with the business, to whether you're managing expectations or just inspiring confidence that they can look at a dashboard that you're giving them, and with not 90% conviction, but 100% conviction, say, I know this is high quality data. I know our team is shipping good stuff. Let's look at this data and make decisions using that, not our gut. That really is what we're trying to get to. And our path to that world, we think, is through preventative, proactive data quality. And again, just like another way to visualize how bugs affect software teams versus data teams, right? Like, if the software is still working, right, it can be a little buggy. Like, anyone here who works at a startup, right? Users, early users will say, hey, I'm running into a bug here, a bug there, right? And your team jumps on it quickly. That doesn't necessarily crater trust in any significant way. But with data teams, again, all of our customers, when we're talking to them, the people that really see the value of Datafold fast are the ones that have had these really high visibility bugs that then throw into question all the work they do on all their other data products, and they have a really hard time earning that trust back. It's like in a relationship almost. You can't just do it with sheer brute force. You have to do it with time and patience. And so the way that we like to look at this, and really the ethos that we try to share with our customers, is, this trust needs to be treated like this delicate flame that really can't go out. And you need to communicate this to the business as well. So, like, it's almost like the business team, I think, doesn't really understand what the data team has to go through when they say, hey, can you pull this number for me? Hey, where's the data in this dashboard come from? They're asking these questions where they don't have the technical context to understand what it might take to go grab that number or make a data product that answers a certain question. And, when they ask a question like, hey, where does the data in this dashboard come from? And it takes 45 minutes for that question to get answered, that entire time, who's ever asking that question, their trust is slowly eroding. Like, hey, does our data team really know what they're doing? Do they really know what's going on? And so I think having a really open line of communication with the business about this kind of trust relationship that you need to have is really the first step into building that culture where, you prevent these data quality issues from happening, and you maybe prevent some unreasonable business asks that you probably won't be able to deliver on anyway, that would just actually serve to erode trust, and that the business wouldn't want to, even ask if they knew the proper technical context of what they were asking for. And so that's really how we see things here at Datafold. And that's basically the talk. So if there's any questions or anything, more than happy to jump on and answer any of them, especially as they pertain to Datafold and the products that we sell.
Yeah, awesome. That was a fantastic talk, Tim. Really sort of, I guess, I think that's perhaps something that us data engineers, potentially we're not always the closest to the business.
Sure.
Generally, you've got sort of data engineers and perhaps data warehouse developers in between a data engineer and sort of business facing. We're just kind of replicating data out of, to the best of our ability out of
Yes.
source systems and the like. And so just specifically on Datafold, we're definitely not like a sales platform for products, but it's good to understand what great sort of startups are out there and kind of how you sort of help solve some of these challenging problems.
Sure.
How does Datafold help in terms of making data land a bit more reliably and being able to sort of you know do testing and stuff like that?
Yeah. So our flagship product is called Data Diff, and so what Data Diff does is it, and we also have a CI integration for this tool that makes it really easy. But essentially, it helps you compare data sets between your production data models and when you're about to maybe make a change to some SQL logic in a core data model. Will help you instantly compare what the data output of that change is going to be to your original prod data. So you can understand, hey, if I write a quick 4-line SQL hotfix for some bug that popped up, you can see exactly what the downstream impact of that issue is, or what that change is going to do to the data. So maybe if it changes the total amount of rows by 50%, you go, wait a second, this was not supposed to change the total number of rows at all. This is a bug, and you can actually not ship that into production for it to fester silently. You can catch it right there before it actually makes its way into production and into a dashboard that a user is looking at. So that's our flagship product. We also have a data catalog where really it's a pretty lightweight data catalog, and really what it's there for is to help you interact with our lineage. So one of the other things we're really good at is column level lineage. So for folks out there who are using DBT and love the table lineage, we take it one step farther. And so yeah, that again just makes it really easy to understand and intuit what's happening with data and like the downstream impacts of changes in a super efficient manner. Those questions like, hey, where does the data in this dashboard come from? That's a specific quote from a customer. Go from 45 minutes of writing SQL to, hey, here's a screenshot of the column level lineage. Here's exactly at the column level where the data in this dashboard comes from. Again, help support that flame of trust between the business and the data team. And then we also do have some monitoring tools as well. So tools that help you, as opposed to just stopping breaking changes from getting into production, also an anomaly detection tool that, when things inevitably do break in production or something happens that actually, wasn't the data team's fault, but is still the data team's responsibility. We help you find out about that first so that you can address it, get in front of it, maybe send an email to a business stakeholder saying, hey, we noticed there's something wrong with this dashboard. We're on top of it. Again, the dashboard might still be wrong for a bit, but even just doing that helps, again, maintain that trust relationship with the business. So all the products that we build and the products that we'll build in the future all sort of roll up into this, trust that the data team has with the business and that the business has in the data team. They're really just there to support that and strengthen that.
Yeah, it's the classic. You're not finding out like a month after the fact from a business stakeholder.
Bingo.
All your data's busted. You're actually aware of things breaking up front and even potentially before you merge your code in, sort of thing. So that sounds amazing.
Exactly. Less colorful emails from stakeholders is our goal ultimately.
Sounds awesome. Well, look, thanks so much. I know it's really late over there in Austin, Texas. Sounds
All
like
good.
Datafold's super exciting. So all the very best. Hope you, have a lot of fun, sort of developing and, selling that product and fingers crossed, some of the data engineers here locally can get a bit of benefit out of, the awesome innovations that you're bringing to the field. So Keep doing what you're doing, man. Appreciate
Sure.
your time.
Absolutely. No problem at all. Thanks so much, everybody. Take it easy.
All right. Chat to you later, Tim. Thanks so
Yeah.
much.
Bye.
Cool. So that's it for the February edition of the Data Engineering Meetup. Really appreciate all your time today. Thanks for dialing in live to ask all of your questions. Hopefully, you got them answered. Feel free to sort of drop further questions in the Slack group. We're really looking forward to getting the meetup back in person. I think, things are sort of stabilizing here in Australia, and we're noticing a lot more in-person events happening throughout the country. So we're keen to join in and get everyone sort of back together, enjoying a slice of pizza, chatting about sort of what you're finding interesting in the field of data engineering, the sort of problems that you're working with at the moment, trying to solve. So I think that'll be really cool. As mentioned, we're planning an in-person hackathon and an in-person conference this year. So please stay tuned for details. We'll get them to you as soon as we've got them all organized. But yeah, keep being awesome. Ciao for now. See you next time. Thanks so much. Bye.